at that. I am on it on a Monday. Proportion, right? Proportion, AL, relationships. Now, to this point, yeah, it might be a tad bit aggressive, but I told you over and over again last week that even though it's awkward that I normally don't collect on a Monday, I am collecting today. And if you really don't know what grit actually is, it's probably confusing when us teachers keep saying, like, get some grit. So let's make sure we're on the same page, right? I like how this article starts. The basic definition of grit is passion and perseverance for a long-term, meaningful goal or goals. So remember, you chose to come to Phoenix because we're different. And part of one thing I've really learned about Phoenix is, like, there's a definitive progression as we move through the year. And sorry, it's not quarter one anymore. Like, there's a definitive, like, quarter one kind of honeymoon period where we're real nice to you guys and kind of take it sort of easy. Now, me, not really. I just assigned math homework pretty much out the gate. We went to camp, so you guys got a little bit of a soft opening for math homework. But yeah, it's time to step it up. So if you are a person that needs to step it up and determine, like, I got to up my grit level, yeah. So it's the ability to persist in something you feel passionate about and persevere when you face obstacles. So if you're sitting here and you're like, my homework's not done, I did everything I could, but you didn't use homework help, then you didn't do everything you could. If you didn't reach out to me with your difficulty, you didn't do everything you could. Right? So I'm not trying to make anyone feel bad. I'm trying to motivate you. Right? If you need to up your level of grit, do it. Right? It's about dedication and commitment. So, yeah. Are you committed? And if not, that's all up to you. You just got to make the choice. Like, I am committed to reaching these goals. So today we talk about proportional relationships. Anybody want to read this morning? Eric, can you actually see that from way back there?
Yeah, just
all right. I test. I test for Eric.
You can just ask me to move. Thanks. Grocery stores often advertise special prices for fruits and vegetables that are in season. You might see a sign that says, special today, buy 2 pounds of apples for $1.29. How would you use that information to predict how much you need to pay if you want to buy 6 pounds of apples or just 1 pound of apples?
Pause. Turn to your neighbor. Talk about that. How could you decide 6 pounds, 1 pound? What do you do?
Well, first you gotta figure out how much one but if it wasn't an even number, then
No. All right, Araya. Bring it back. Araya, how do you figure out 6 pounds, 1 pound? What do you do?
Okay, so there's 2 different ways. Depending on if it's like an even number that you're trying to find, then you can just multiply it by like 3 to get 6 pounds.
Okay.
Or you can multiply by 4 to get 8 pounds and so on and so forth. Or you can divide that by 2 to get the singular pound and then multiply it to get
I love it. Luz, what about 0 pounds?
0 pounds?
What are you going to pay for that?
I'm not going to pay for it, you don't have to.
Wow, Luz, you're a really good ventriloquist. You threw your voice. It sounded like it came right out of Lily.
No.
So, yeah, like Luz said,
Lily.
nothing, right? If you don't buy any apples, it's nothing. So, Eric, if you want to finish us out.
Alright, the way that the cost of apples or grows or shrinks allows you to use a variety of different strategies to predict and estimate prices for different amounts of apples. In this section, you will explore different kinds of growth patterns. Wow. You will use those patterns to develop strategies for making predictions and deciding if if answers are reasonable.
Thank you very
So just
much.
to make sure this isn't like the talk, right? Like growth patterns. Like we're not leading anywhere else.
No, thank you, though, Toby, for making it awkward.
Yep.
Can always count on you, man.
That's what I do.
So, proportional relationships. On your white sheet, where it says proportional, get your pencil out. You're warmed up this morning. If you haven't used it yet, you might need to stretch if it's been 3 days since you wrote anything.
What?
What?
Wait a second.
It might be. It was Friday, right?
Hey, wait a minute. No.
If you didn't have any homework,
I've been writing.
You don't write anything?
I'm not sure what I wrote this week.
Writing.
I typed a lot of things. Proportional means that one value, you should write this on your white sheet. Sorry, I can't answer a question right at the same time. One value, example, cost, in parentheses is just an example, right? One value, cost, is a multiple, meaning we can get to it through multiplying, of the other value, such as, yeah, but this is already purple, such as apples. So the cost of what you buy is a multiple of the number of apples. And if the number of apples is 0, well, anything times 0 is 0. So a proportional relationship is where one value is a multiple of the other. What this looks like, gonna have to become an artist real quick. What this looks like when we go to graph it, draw an XY real quick. It doesn't have to be fancy.
Where on our graph?
Up to you.
So we just.
It is. Here's your 0 apples, $0. So here's like dollars and here's apples. Bless you.
All right then.
It is a straight line through the origin. Those are the two things that you're looking for when you look at a graph to see is it proportional. Is it a straight line? Is it through the origin? If it checks both of these, it is proportional. If it misses either of these, it's not. Linear.
Not proportional.
It's called line R. Seriously, linear. So, Gustavo is fortunate. He has a really nice grandma. So, Grandma Gustavo sets up a college fund. Now, 5 years ago, right, because you got to start planning ahead of time, Gustavo's grandma put some money in the college savings account, and the account pays simple interest. Couldn't write that down. We don't quite know what it is yet, but sounds like a word that matters. Simple interest. I don't know, but it apparently is not complicated because they called it simple. So
That's
Nice.
you know when you like introduce like this is my annoying sister, like this is simple interest. Anyone know what interest is? Nick?
So then, if I get Zach $10, he would have to pay me back. That's $10 for like a week. He'd pay me $12
Ooh.
because like 5% interest.
So it's getting more back than what we started with. Okay, I dig it. I like it. Morgan?
Kind of what Nick said, when you put money into a bank account, basically they loan it out to people. And since they do that, they give you like a small percentage back.
Morgan knows all about this. Yeah, that So the easy way, the simple definition that we can say for simple interest is it is money earned. You should write this down. On money. It's money earned on money. But it goes both ways. And I'm on the bad side of it.
Jeepers, well, that sucks.
I have borrowed money for a car, money for college, and money for a house.
Is this a real example?
So,
And
yeah.
Oh.
Am I a real person? Do I really go home to a house at night in a
Well, you're
car
just
that I...
making
No, dude, come on, man.
Dude,
Don't
this
be,
is for real. So, like,
Don't be global, Nick.
I could pull up my bank accounts. No, I tell you when I'm lying to you. Like, right, if I was making something up, I'd say, I'm making this up. So, for real, college, car, house. Right? I don't think I really have any other loans. My credit cards I pay off every month. So, those things have an amount of money. Let's call that $200,000. And that's probably being nice because my house is worth a decent amount because it's a house. And guys, when I'm talking money with you guys, I try to be very honest, but I don't. I'm trying to figure out how to say this. Kids have a very skewed perspective of money. $200,000 isn't really that much money, especially when we're talking house, car, things put together. So please don't sit and be like, oh my gosh, Mr. Hudson has I'm just telling you examples to be real with you. So let's say my house, my car, and my college, $200,000 that I borrow from the bank. Do I just pay back the bank $200,000? No, I probably pay back the bank $250,000. Really, because that home loan. Anyone know how long the loan on a home normally is? Really? If you think the loan term on a house is 5 years, raise your hand. If you think the loan term on a house is 10 years, hold on. 15, let's say the most normal. 20? You think you got 20 years? 25? 30? The normal home loan is 30 years that you're agreeing to. Now, that doesn't mean you can't pay it off before that, but that's the amount of interest they apply to your account. So as Zach said, about 20 years, that would have less interest, right? Because if they write up the loan planning on you having their money for 20 years, or 15 is normally the shortest that people talk about. So Gustavo's grandma puts money in an account after 5 years. After 5 years. It's worth $500. Okay? Now, Gustavo graduates in 5 years, like you guys do.
Wait, what?
Weird coincidence.
Weird coincidence, right? Hold on. You're going to have to talk with a neighbor and then I'm going to random card and ask people. Gustavo thinks that in 5 years from now, when he graduates, the account will be worth $1,000. That makes sense. He's like, well, 5 years ago it started. It's now worth $500. 5 years from now, it should be worth $1,000. Turn to your neighbor and talk about that. Do you agree with him? Is he wrong? And you go to college for less.
How much money did he put in?
Checking if people are the definition right now. Biggest thing in the past is people struggle with time. Molly brings up a good point. Molly said, well, some grandmas forget how much money they, gave the kid or whatever. So we go to the bank. right? And we're like, man, we can't decide. We're having an argument in math class, and the easiest thing is just to ask you, because who wants to do math? So we go to the bank, and well,
Takes a minute to get there.
does take a minute to get there. We ask the bank to show us his account balance,
I don't think that's like allowed.
and they pull up this graph. Well, Gustavo's with us, of course.
Yeah.
So
They just want to look at a random person.
they say, okay, here we are, right? They say, here we are. The account has been open for 5 years. Here we are. Your account is worth 500. Mirabelle, can you tell what's going on here? Like what this graph really tells us, what it shows us?
The money, you're getting more money every year.
We are getting more money every year. Turn to your neighbor, talk for 30 seconds about, is this proportional? And what does it show us? Tell us. Go. Yeah. Money?
If I put $10 in investment, and a week from now, I go back, wouldn't it be like $9? Because like they invest so much money in it, and then they make that money back. Isn't that how like?
So if you have a decent account, you will get more money back than what you started with.
I know, but like, it should be like because isn't like the bank takes some money, invest it in something, and then that's how they make that money.
We'll talk. Give me a minute. You're off on a tangent. Your question's good. We need to set some foundational knowledge. We need some steam first. Hey, I realize we should probably define the word that we use in the definition. So, guys, with your grit has to come a bit of like, I care, right? If I use a word that you don't know, it's your job to make me do my job and explain that. The origin is this point where the x and the y axes meet. So if you didn't know that, that wouldn't have made sense when you wrote it down, and you should have asked. So if we come back over here, where'd my cards go? Oh no. Nick, what do you think about Gustavo and his college fund? What did you and Zach talk about? Yeah, he's making $100. How'd you say that?
We found where money first came from, which was like 0 years technically.
Okay, 0 years technically.
Or then 5 years, which is a life mark. It began at 400 and now it's up to 500. And then no, 400.
That over here. So, did everyone see what Nick saw? Like, oh, where the money started was $400 at 0 years. It made $100 in 5 years. So, if nothing changes, right? She doesn't put any more money in. He doesn't take any money out. It should make another $100, and we'll have not 1,000. What was Gustavo thinking? Can you explain why he thought that?
Because he just multiplied, he divided it by 2.
Ah.
No, he multiplied it by 2.
Yeah.
Because he was like, well, this makes sense because if it's 5 years and I'm getting $100 each year, then I get $100 5 years.
Does twice as much time mean twice as much money? No, because it starts somewhere. This is not proportional because it starts somewhere, right? Not the origin. It starts at not the origin. All right, if you are on something else, please come back with me. Let's check out 23. What do we see happening here? So take a moment. You don't need to write anything down quite yet. what do we see happening here? What can you tell from this table? Like, if you got this table and you hadn't already been talking about this problem, what do we see? Take at least 30 seconds.
Okay, so every year it's gaining $20.
Do you know how we could phrase that as an application for how much money you'll have? Is that the total amount of money? What about the previous year? All right, Olivia. What did you notice here?
We noticed that it was going up by 20, like 40, 60, 80.
This is going up by 20. What about the other numbers? Like these?
And it's going up by 1, so it means $20 a year.
Ah, so $20 every year, right? $20 per year. So then, Nick, Zach, and I were having a good conversation because Nick will get off topic if I don't steer his brain. He's like, if I invest a penny and then I come back to it, I'm like, Nick, solve this problem. Well, it's an interesting thought, but we needed to solve this problem. So we were having a really interesting conversation. So Nick, tell me what you said about the 20 and that you were saying like X and Y and things like that.
Then X.
What is X?
Years.
Okay, so Nick said make X your years.
Times 20.
X times, so I'm going to write it 20 times X.
Ooh, and then you need to add parentheses.
We need to add, okay,
I'll
sure.
multiply that first.
Zach seems like he wants to help you.
Yeah. And then you gotta add $400 to that.
And then we gotta add 400 to this. So let me scroll down. Everyone on your paper, please. His balance. And again, this is one of those words where you should ask if you don't know. Balance is not talking about like balance. What's balance talking about? Toby?
Balance is the amount of money that you actually have.
It's your total. Dude. It's your total money. So, balance, Zach just said, we start with 400 plus, I have like some side conversations, and unless you guys already know all this, I kind of am confused. So this is our start. It's our initial value. And then this is, what did we call it?
Oh, the simple interest.
It's the simple interest. All right.
You still need parentheses because you automatically
Yeah, you don't need the parentheses. They're nice, but you don't need them since multiplication will happen before addition anyway. But they are nice to use. Like, there's no harm.
So then, over time, does interest get better?
Not if it's simple.
So then.
So that's, hold on, let me pause you on that. Nick is asking the question that separates simple interest from the other kind called complicated interest. I'm kind of not joking. So give me your eyes. I got a lot of people not with me. I kind of need you looking so I can tell that you're at least partially listening. Simple interest. No joke. Its real name is simple interest, like in the bank documents. The other interest is essentially called complicated. Not joking. It's called compound interest. Compound interest, and we'll talk about this later, Says, same situation as earlier. Zach borrows $10. And he keeps it for a week, and you're like, yo, bro, you owe me 12. And he's like, yeah, no, I still don't have it. And you're like, all right, whatever, compound interest, ka-ching. So Zach keeps the money for another week. Now this week, instead of Nick charging him $2 extra, he's like, hey, Zach, this week cost you $3. You now owe me $15. And Zach's like, well, bro, one, you're a ripoff. Two, I still don't have the money. And Nick's like, whatever, compound interest, ka-ching. So Zach keeps the money for another week. And instead of charging $2 like the first week or $3 like the second week,
He charges $4.
he charges $4 now. And Zach owes him a total of $19. Hey guys, I'm describing something that happens to many, many, many people every single day. This little plastic card is seriously the death sentence for somebody. I'm covering up some of my number just in case you have really good vision and you're gonna go use my number on Amazon or something. So hold on. So without me even trying, almost on the daily until you opt out, credit cards get sent to adults. Just here you go, here's your credit card, have it, have fun. Let's imagine your limits, because credit cards have limits. To start, let's say they don't trust you very much and they say your limit's $1,000. No joke, that's a low limit. My limit on my one card is $12,000. $12,000. I can go just one day, charge up $12,000 before they stop me. Then they stop you and they're like, hey, slow down, take a breath. That money keeps accruing interest till I pay it all off. And there are so many people in the world that are just stuck in the battle of paying things off that they never catch up. They're just paying down the interest, but then the interest happens again. And they pay down the interest, and then the interest happens again. And they pay it down, and it happens again. Like, this is a battle you don't want to get into. This is why I teach math, especially this level. I'm trying to educate you so you don't make those mistakes.
So you don't ruin your life.
Yeah, and go into a financial hole. Yeah.
You have a credit card or a debit card?
A debit card is money in the bank that you pull from. A credit card is you borrow money short term from the bank.
That's what like depositors.
Nikki.
Why debit is better than credit.
Yes, because debit is your money. Yep.
Debit is your money.
Nikki. Bella. Hi.
So once you get your like credit card, so like do you have to like pull like ask the bank to put money onto the credit card or is it just on there?
Nope. So they tell you what your limit is, and I actually have some documentation out the hallway. I may have ripped it down because it got all messy. I'll try to bring in when like, so banks are constantly sending like, seriously, here's a credit card with us, and if you respond and say, okay, sure, they'll send you an actual one, but they normally send you like literally like a cardboard like fake credit card in a way, and they'll tell you you have up to this much money. Go wild, right? But they also tell you your interest rate. A normal interest rate for a credit card is between, actually make a guess, write down on your paper what percent, I just want to try an experiment with you. Wherever, what percent, I just want you to commit to something. I don't care, I just want you to commit a guess. So if you spend $1, how much do you think you have to pay back if the interest happens only once? How much do you have to pay back? If you, or really think if you spend $100, right?
$100 fine, sir.
Is it $101? Is it $102? Like, if I spend $100 just to make it a little bigger, what percent do you think? Who said?
I'm saying 5.
Here, put your hands up. If I go past your percent, put it down. If I go past, if I just then put the number in your head. If I go past your percent, put it down. 5% is nowhere close to a rate that you'll get on a credit card. 10% would maybe be if you had really, really good credit and you paid for your credit card. 15%, you'd be lucky, and the bank has to trust you. 20% is essentially what my cards charge me. 25 to 30% is what's normal. So let's think about this. If you spend $100, you go buy a new TV, Black Friday special, whatever, $100, and you don't pay it back like quickly, and the interest happens. Now I'm simplifying a lot of things right now.
Which interest are we doing? Credit card.
Yeah, like so, if it was 30% and your interest fully cycles, now it depends on the terms of your credit card, you'd owe them $130. Or you could have just waited and saved up your money. All right, let's talk about birdseed. I know it's not as fun as mine. Yep. Yeah. Look, it's becoming winter, but the birds still exist. If you want to be kind to our animal friends, some some migrate, some hibernate, but some hang out. They keep going.
You mean like
Write this down. I'm a leaky tire. I'm a babbling brook. 4 pounds of birdseed. 4 LBS is how you could write that down. 4 LBS. Anyone know why it's LBS? I always like to drop this knowledge on you guys.
why is it LBS?
Actually, let's talk about it tomorrow. I want to see if any of you will actually look it up. Figure out why pounds is abbreviated LBS.
Okay.
I challenge you. It has to do with things we've talked about this year with like stems and cultures that words relate back to. So I will tell you that much. 4 pounds, $27. Draw this table real quick. You can just T-chart it. So T-chart this way, or you can vertical T-chart it if you really want. You can vertical T-chart if you want. So you could go like pounds and dollars, like that vertical T-chart. 0, 1, 2, 3, 4, 5. Careful. There's a jump here. You can put in 7 if you want, the big jump. Bum, bum, bum. Now, I think we can all figure out if she buys no bird seed, what should it cost? $0. 4 was 27. How did she figure out the 1 pound? Turn to your neighbor and talk about what she did to get to 675.
Well, like, if she had one, if she had one, whole pound, and then the normal,
Question? Oh. May, what do we do to get to that 675? Yeah, always. Meredith. Yeah, I gotta shuffle these. Lydia, do you know what we did to get to that 675? Yeah. This obviously means we gotta talk about this. Lily?
Will be divided by, you would divide 40, or no,
Everyone write this down. Dollar symbol per pound. Per tells us to divide. So this is $27 divided by 4. Per tells us to divide. So anytime we want to solve a per, it's going to involve a division. Now, this is where people get confused. They're like, but wait, if apples cost $1 per pound, that's not division. They did division to get there. Right? So if somebody gives you a per value, they did division to get there. So we do 27 divided by 4. it comes out to be 675. And then, like when we think back to the apples, instead of just working with even amounts of pounds, now I can work with any amount of pounds, right? Because I can just multiply up. Because the cost of the apples, or sorry, the cost here of birdseed, the cost for any amount of birdseed is $6.75 times, you're right, it is dollars,
Whatever amount.
times your weight, right? So X or W or whatever you want to plug in, your cost is $6.75 times W. That means this is proportional, right? One value is a multiple of another. So 2 pounds, $6.75 times 2, $13.50, I think.
Do you ever get injured?
Because 6 times 2 is
20, 25.
75 times 2 is.
What is 675 times 5?
Whoa.
3375?
Yep.
Now wait, is there an easier way to get 8 pounds? Ooh, we could just double it, right? Because if we have 4 pounds, if, put your pencils out for a second, not even down, just out. If it's proportional. Alright, set it on the table because now people are distracted. If the relationship is proportional, what we do to one number, multiplication or division only, what we do to one number, we can do to the other. So if we double our weight, we can double our price and get 54. Any preguntas? What is it? So 75 would take us to 34.50, and then $640.50, I think. It'd be 40.50, yeah. Double the 20, double the 25. You have the next 2 to 3 minutes to work on homework problems. I don't know why you put things away. Yeah.
Okay, mine are maybe easier, but more kind of how my brain works.
Okay.
So on the even numbers, I take the cost for the even numbers and I just multiply by 2
That's fine.
to get like 46.
If that works easy for your brain, that's perfectly fine.
I need the homework from last week.
They are still actually loaded. There are only 2. It's 411 and 412. So this is 411, I believe. Yep. And this is 412. And then we did a Desmos design challenge thing. That means you didn't really miss anything with that. Thank you. Hey, here, if you want it, here's the design challenge thing that we did. And it was all dealing with scale. So the fact that each box is 5 feet long, and then each square is actually 25 feet because it's 5 by 5. So then we designed a house with a driveway and calculated some areas. And then this stuff we didn't quite get to yet. But there's that just so you didn't really miss anything. Thank you.
I apologize to get some angry text to myself.
Why would they